Welcome back for more AP Stats practice test. Here we're going to be looking at questions from the Chapter 8 practice test. And for number 4, we have the weights of 4 men have an average of 175 pounds and a standard deviation of 15 pounds. What is the standard error for the mean? So the standard error for the mean is going to be the standard deviation S of the sample divided by the square root of the sample size. So all we really need to do here is substitute our values into this formula and then do a little bit of division. Not a whole lot to this one. Let's take a look at number 5 now. Here we've got the 95% confidence interval for the mean reading achievement score for a population of 3rd grade students is 44.2 to 54.2. What is the margin of error for this interval? A couple of really handy formulas for if you have any confidence interval A to B, the margin of error is always going to be B minus A divided by 2. The B minus A part, that's going to tell us the width of the interval, and then half of that width is going to be our margin of error. And then the other formula that goes along with that is the point estimate is going to be the average of A and B. So A plus B over 2 should give us our, in this case, the mean of the sample. Let's substitute our values and then just compute the value. So the margin of error is just 5. Moving on to 6. We've got the level of dissolved oxygen in a river is an important indicator of the water's ability to support aquatic life. You collect 20 milliliter water samples at 15 randomly chosen locations along the stream and measure the dissolved oxygen. Here are the results in milligrams per liter. First of all, check the assumptions for a t interval and then construct and interpret that 95% confidence interval. So it's probably more efficient for us just to go all the way through the construction. So this is going to be the 4-part plan. State, plan, do, conclude. Now we're trying to figure out, it doesn't really say here, but we are trying to figure out the average, the average dissolved oxygen. So for state, we're going to say that mu, and you can pretend that's the nice letter mu. That's going to be the true mean dissolved oxygen in the river. Now, a couple of things here is the true mean is definitely a phrase that I'm going to hang my hat on. Definitely put that in there. We're measuring dissolved oxygen, and then we're going to give some kind of an indication about where we're measuring that oxygen, or what is this sample coming from. And this sample is coming from locations along a stream. So I should change that to a stream, actually. The confidence level here is given to us at 95% right here. And that's everything we need to do in the state part of our 4-step plan. That goes by quickly. Next we have plan. What is the name of the procedure? Yeah, this is just a t interval for mu. Anytime we do this for mu, it should be t interval. The only exception here for mu is if we're trying to compute the sample size, that's when we would use z. Every other time, you're using mu. Now the conditions for a t interval for mu, there are 3 of them that we're going to concern ourselves with. The first one is random, and I'm looking for something in the question that tells me that this is a random either assignment or a random choosing. So I see right here 15 randomly chosen locations along the stream, and I'm going to quote that. Next is the 10% condition, and if we chose, well, this 10% condition, so 15 needs to be less than 10% of all locations along the stream, and that's a pretty good one for us to think about. 15 times 10 is 150. And as long as there's more than 150 locations along the stream, then this 10% condition is satisfied. So I would write that it is reasonable that there are more than 150 locations along the stream. Now the last condition for a t interval is going to be the normal condition. We have to somehow be able to conclude that the sampling distribution here is normal, or at least it has a normal shape. Now the first thing that we go to is, do we know that the population is already normal? And reading through here again, there's nothing here that says that the population or that the all of the samples have a normally distributed dissolved oxygen level. So that doesn't work. The second thing that we could go with would be that we have a large sample size and we could use the central limit theorem, but we only have a sample size of 15. That's definitely not greater than or equal to 30. So that takes care of the central limit theorem. Can't use that. The last thing that we can do, and we could better hope that this works, is that if we can see that the sample itself is distinctly not non-normal, then we're justified in believing that the population is actually normal. And if the population is actually normal, then the sampling distribution is normal. So we're not actually going to check that the sample is normal. We're just going to check that the sample is not non-normal. So it's a little bit of play going on here. We're not checking for normal. We're checking for non-normal. Now the easiest way to do that is to grab your calculator, put all of those values into L1, head to the stat plot menu, and then check the normal probability plot. Just as a refresher, the normal probability plot is this very last selection that I'm making right now. And data list is in L1. And then once we have that, let's see, data axis X, that works fine. Mark, make it the square. Yes, my eyes hurt. Blue that's a good color as any. Next we're going to do zoom and 9. And do we see a distinct curve pattern here? And I don't see a distinct curve pattern. So this definitely looks like it could have come from a normal population. So we would write that the normal probability plot does not have a curved pattern, so T procedures are okay. Next we have the do portion. So the general formula is point estimate plus or minus margin of error. The specific formula, x bar plus and minus t star s over root n. Let's calculate x bar and s right now. Grab your calculator, get to the home screen, and calculate 1var stats. Frequency list, we're just going to put a 1 there. Okay, we're just going to leave it blank. And then we're going to calculate. And that should give me the only values that I need from here are going to be x bar and sx. So we're going to substitute that in right now. I should have mentioned that we also need sample size. Now, this is where some students kind of, I guess it kind of gets to me. We need to decide on how many decimal places or how accurate do we want our answers. And if you take a look at the data presented, all this data is at 2 decimal places. So I've made the decision to take my x bar and make that 2 decimal places as well. Now the next thing that I'm going to say that since I have my x bar at 2 decimal places, I want my s to go 1 more decimal place than my x bar. So my s, I'm going to round it to 3 decimals, 0.940. We talked about getting t star, so let's go ahead and grab that website. we want how many degrees of freedom? Sample size is 15, so degrees of freedom is 14. Confidence level, we want that to be 95%, and let's calculate that. That gives me 2.145. 2.145. So I have all the numbers I need, and I just need to calculate that margin of error. And that puts me at a margin of error of 0.521. Lastly, we're going to conclude. So go and grab that sentence frame. We are 95% confident that the interval from 4.249 to 5.291 captures the true, and then I'm going to come back over here. I'm going to grab this, the true mean dissolved oxygen level. True mean dissolved oxygen level in this stream. And we should probably put units here. There we go, milligrams per liter. I'm going to read it one more time just so that I know I don't have to adjust for readability. We're 95% confident that the interval from 4.249 to 5.291 milligrams per liter captures the true mean dissolved oxygen in the stream. Sounds wonderful. Now we're going to go to this last one for this video, and we have the polling organization announces that the proportion of American voters who favor congressional term limits is 64% with a 95% confidence, margin of error of 3%. Wow, okay, so this means that if the poll was conducted again the same way, there's a 95% chance that the fraction of voters favoring term limits would be between 61 and 71%. The margin of error has nothing to do with any individual interval. So since this gives me an interval estimate, 61 to 67%, I can cross that off because that has nothing to do with the interpretation for a confidence level. Letter B, there is a 95% probability that the true percentage of voters favoring term limits is 61 to 67%. That's also incorrect, pretty much for the same reason. Also, that the true percentage is either between 61 and 67%, or it's not between 61 and 67%. There is no real probability to it. Letter C, if the poll was conducted again the same way, there's a 95% probability that the percentage of voters favoring term limits in the second poll would be within 3 percentage points of the term limits of the first poll. So that is kind of a weird response. And I'd have to say that's a no for me. Next one, among 95% of the voters between, okay, so this one has that same interval again. So this has got to be wrong also, right? Meaning our answer should be E, none of the above. Now I feel really bad about leaving you without the actual interpretation of that 95% confidence interval. And if this poll was conducted many, many times, about 95% of those intervals constructed would contain the true proportion of American voters who favor congressional term limits. A confidence level is a success rate of a process. It doesn't have anything to do with any individual poll or any individual results. It has to do with how many times is this process successful. So that is the end of this video, and we will see you for the next video on the Chapter 8 practice test.